In the last two videos, we have seen that how to use the syndrome word to detect the error while you are storing the data bits into the memory. And same time, we have discussed a little bit about check bits. And same time, we have discussed about the check bit positions. And also, we have discussed about how to place the data bits, right? An example, we have seen that if the data bit size is 8, then how many bits will be there for check bits? All these things we have discussed, right? Okay. So please remember these four terms in this syndrome word calculation for error detection, right? Okay. So first one is this syndrome word calculation we are using for error detection, right? Okay. And second one, this is the syndrome word, right? The previous version is Hamming code error detection and correction also there. But here we are going to see that syndrome word calculation for error detection, right? Okay. So here we need to have the check bits and we need to have the data bits, right? Okay. And here I'm going to take the example of this one. You just see that I'm going to take 8-bit data, right? Okay. So this is my example. I'm going to take it. So in previous calculation, I have said that if the data bit size is 8, you should have the 4-bit check bit, right? 4 bits will be there in the check bits, right? Okay. And same time, how you can place it, I have mentioned that how to go for 12-bit positions, right? Okay. You know, because 8 plus 4, 12 will come. So, okay. So here 1, 2, 3, 4, and 5, and 6, 7, 8, 9, 10, 11 and 12. Okay, so in the previous one I have said that how to place the check bits, right? Okay, so here check bit position 1 and check bit position 2 and check bit position 4 and check bit position 8. So this is how you need to place the check bits in the 12 bits, right? Okay, the data bits you need to place it here, data bit 1 and data bit 2, data bit 3 and data bit 4, data bit 5, then data bit 6, data bit 7 and data bit 8. So this is how you need to place the data bits along with the check bits, right? Now, so if I am storing this particular data bits into the memory, how can I calculate the check bits? So in the previous video, I have seen that how to calculate the check bit positions I have mentioned, right? Okay, so you have, please check the previous video. I have mentioned that how to calculate, right, the check bits in the how to identify or how to calculate the check bits, right? Okay, so here we are going to see this particular example. How can I calculate the check bits for this particular data bit, right? Okay, so now I am going to place the data bits here, right? Okay, so data bits are here. So minus 0, 0, 0, 0, and here 0, 0, 0, and 0. Right? Okay. So now how can I identify the check bit position 1? Right? Okay. So this is my check bit 1, check bit 2, then check bit 4 and check bit 8. Okay. So now you need to verify that if I am going for check bit 1, I need to start from here. Check 1 bit and leave 1 bit. And check 1 bit and leave 1 bit. Check 1 bit and leave 1 bit. Check 1 bit and leave 1 bit, check 1 bit, leave 1 bit, check 1 bit. Like that it will go frequency. This is how frequency will be there for check bit position 1, right? Check 1 bit, right? Okay, so you need to start from check 1 bit, so nothing is there. So check 1 bit and leave 1 bit and check 1 bit. Here while you are checking, 0 is there. So my first one is 0. Then I need to put the XR, right? Then check 1 bit and leave 1 bit. Then check 1 bit and leave 1 bit. 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 Right? Okay. So wherever arrow mark, upper arrow mark is there, I need to check. Right? So this 0 I have added. Now this 0 is there. So 0. Again XR. Again this 0 is there. Again one more XR. Then this 0 is there. Now this is for check bit 1, right? Okay. So check bit 2, again what I need to do it here, you need to understand that. So you need to start from where? Check bit position 2, right? Okay. So here you need to start from here. Then now what you need to do it, you need to go for previous one is check bit position 1. You need to your frequency is 1 bit, check 1 bit, leave 1 bit. But here check bit position 2. So you need to go for check 2 bits, leave 2 bits like that. So here you need to go for check 2 bits, right? And leave 2 bits. Check 2 bits and leave 2 bits. Check 2 bits and leave 2 bits like that. So here there is no bits, so we are leaving. So now you just see that wherever I am upper arrow mark is there, you need to add it here, right? Now you just upper arrow mark is there, but check bit position 2 there is nothing is there, so value is not there. So data bit 1, so I am adding it here, right? Again here 2 check bits are there. I need to check two bits. I need to check it. So 0 0. So 0 plus 0. Again 2 zeros are there. So 0 0. Right? Okay, so this is how I can calculate the check bit position 2. Right? Now I need to go for the check bit position 4. Right? Okay. So while you are going for check bit position 4, you need to start from check bit position 4 here. Okay, so here frequency will be, you need to check 4 bits, you need to leave 4 bits. Check 4 bits, leave 4 bits like that. In the previous video I have mentioned. Right now, here I need to check 4 bits. I need to start from check bit 4, right? Okay, 1 and 2 and 3 and 4. I need to check 4 bits, leave 4 bits. 1, 2, 3, 4. And I need to start from here, but data bit 8, only 1 is there. After that, there is no bit, so I am stopping here. So here I need to add it. So for check bit position 4, so 3 continuous zeros are there. So what I need to do is 0, XR, 0, XR, 0. So 3 zeros I have added, right? After that I need to leave 4 bits and 1 bit, right? 1 0 is there, added. Fine. Now, okay. So after that I need to go for the check bit position 8, right? Okay. For check bit position 8, what I need to do is, I need to start from 8th bit, right? There you can see the check bit 8. Okay, from there I need to start. Here frequency will be, I need to check continuous 8 bits and leave 8 bits. Continuously I need to check 8 bits, then I need to leave 8 bits like that, right? Okay, so now if I am counting that here, 1, then 2, then 3, 4 and 5, right? 5, the 5 I need to stop now because after that there is no bits. Now I need to check continuous 8 bits, so 5 bits are there, I am checking. Right, now I am adding for this one, right? Okay, here D5 is there, 0, and second 0 is here, and third 0 is here, and fourth 0 is a D8, right? Now what will be the value for, because you need to do the XR here, you need to do the XR. So what will be the XR? If odd number of ones are there, value will be 1. If the even number of ones are available, the value will be 0, right? Okay, odd number of ones. Example, in the out of here, how many zeros are there? 4 zeros are there. If I am having 1, then out of 4 zeros, 1 value is 0. 1 means there is an odd number of ones. The result, end of this result will be 1. But here there is no ones here. So now all the values will be. Now my check bit value will be, how it will be look like. So here C1, C2, C4 and C8, right? Okay, 0, 0, 0, 0. Right? Okay. So now this will be the value for check bit. Now we have calculated. Now you just understand that my data bit, I'm going to store it in the memory, right? This will be the check bit version 1. I did it here, right? Now I need to, example, if I'm going for another one. Now while I'm reading, if there is any error, example, you just consider this one here, right? I'm just going for one more data bit. While I'm reading the data bit from the memory, so I'm going to take it, right? So for that example, if I'm reading the data bit from memory, so how I'm reading this, you just consider that 0, 0, 0, 0 and 1, 0, 0, 0. Like this, if I'm reading, how the result will be. Now for this, I need to do the same procedure. I need to calculate the C1, C2, C4, C8. Right? Okay, like that I need to calculate that is the check bit version 2. Right? Now if I wanted to calculate this one, right, just find out that I am just storing this one here, right? Okay. See here, this is the check bit version 1. The value is 0, 0, 0, 0. I just added here, right? Now I am going for the next version. right? Okay. Now I'm putting the value, then C1, C2, C4, C8 is there. Now I'm just filling this one. Data bit, here data bit 1, 0. Then here data bit 2, 0. Data bit 3, 0. Data bit 4, 1. Then data bit 5, 0. Data bit 6, 0. Data bit 7, 0. Data bit 8, 0. So this is how. Now I need to go for check bit 1, check bit 2, check bit 4 and check bit 8. So this is how I need to calculate it, right? Okay. So now again the same way, here check 1 bit, leave 1 bit. 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 This is how. The frequency will be 1, right? Okay. I need to start from C1. So here how many upper arrows are there? So these upper arrows I need to put it in the XR, right? Okay. First one is data bit 1, 0. This is the second 0. And this is the third 1 is there. Then here 0. And here another 0, right? Okay, fine. So now the value will be what here? Now, because already I told you that if odd number of ones are there, the result will be 1, right? Okay. So now the remaining I'm just going here. Now I need to go for 2 bit questions, right? Okay. Now 2 upper arrow marks I need for. So this is the C2. Check 2 bits and leave 2 bits, right? So check 2 bits and leave 2 bits. Check 2 bits, check 2 bits and leave 2 bits like this. Okay, so first, again the problem is, this is not right, because you need to start from where? C2, right? Okay, so you need to start from here, right? Check 2 bits, leave 2 bits. Check 2 bits and leave 2 bits. Check 2 bits and leave, right? Okay, this is how. So check 2 bits means here 0 will be there, XR, leave 2 bits, and here 0 is there, then 1 is there, after that again 2 zeros, right? Fine, okay. So now here again, you need to go for this again, C4. So C4 you need to start from here, check 4 bits, right? Leave 4 bits. Right? Okay, again check 4 bits, right? For this, here I need to go with 0, 0, 1 and 0 will be there, right? Okay. So here I need to go with 0, 0 plus 1, 0, right? Only 4 is there, right? Okay, here 1, 2, 3, 4. 4 values I need to put it. Now I need to start with C8 here. Check 8 bits. Right, 8 bits, how many values are the 4 zeros are there? Okay, 0, 0, 0, that's all, right? Now I need to find out the value for C1, right? What is the C1? Sorry, here C1, C2, C3 and C4, right? Okay, here how many ones are there? Odd numbers, so automatically value will be 1. Here how many values are there? Again odd numbers, odd number of ones. And here also odd number of ones and here 0. This is how value will be look like, right? Okay, see, this is now you need to understand that this is the check bit version 2, right? Now what I need to do it, I need to calculate the syndrome word, right? How it will be look like syndrome word, right? Okay, for syndrome word, what I need to do it, I need to go for check bit version 1 XR check bit version 2. Okay, so check bit version 1 is what? 0, 0, 0, 0. This is the check bit version 1. So check bit version 2 is what? 0, 1, 1, 1. Right? Okay, so now here the value is what here you need to put it, right? Okay, so here again if you are doing a XR, then what will be available? Odd number of ones. So 1, 1 and 1, right? And 0, right? Now you just see that the 3 options are available, right? Okay, one option is you need to go with that if all the values are 0. This is your syndrome word, right? This is your syndrome word. So syndrome word 3 options, all zeros. There is no error in the data bit while you are reading, right? Okay, and the only 1 bit among these 3. Any one value is 1, then that is not related to data bit, that is related to check bits. Now more than one value, one bit positions are one that represent which location is having the error. Now you just find out which location, and this is 1 and this is 2 and this is 4, right? Okay, 0. Now if you are adding, that is a bit position number 7. Okay, now we need to go for, that is 1, 2, 3, 4, 5, 6, 7. Now this is the error. This is how you can do the error detection with the help of syndrome word. Right? The one more example, if this is the all zeros. Now if my data bit, right? Okay, data bit position is 1 1 1 1, then 1 1 1 1, right? If the any that is a one value is 0, right? Okay, example, this is while writing, right? Data bit while reading, that is 1 1 0 1 1 1 1 1. This is while reading. This is another example you can try, right? Okay, so this is how you can go with the check bit position calculation, version 1, version 2. Then you can go with the syndrome word calculation, then go with the result, that is the error detection. So this is how you can do the error detection with the help of syndrome word.